Welcome to Intermediate Algebra. Today, section 5.5, we're doing equations with rational expressions. So, equations where we have fractions, and some of the fractions will have letters in the denominator, and that will be very fun. All right, you'll have to excuse me. Yeah, I think it's fun. Fully understand that some of you don't. Anyway, let's get started. Steps here, and then I have one little example, and then we'll get to the big, more interesting examples. Step 1. Find the least common denominator. Okay, so this is going to be really, really important because we are going to actually wipe out all of the fractions. But to do that, we need the common denominator. So find the least common denominator. Step 2, multiply everything by that least common denominator. Okay, so make sure that you just, once you find it, you're going to multiply every single piece of the equation by that common denominator. Step 3, solve it. And then step 4, check your answers and make sure they actually work, because one unfortunate byproduct of multiplying by a common denominator, especially if that common denominator has letters in it, is that you may introduce an answer that doesn't actually work. And we're going to call that an extraneous solution, and we'll see that later. So, first example. This one just has numbers in the denominator, so it's not too horrible. Let's see what we did, though. So I have x over 5 plus 3 halves is equal to 1 half. Okay, ignore the parentheses and the 10. That's going to come here in just a second. So I start by looking at 5 and 2 because those are my denominators. And so since they're just numbers, what's the common denominator for 5 and 2? That would be 10. So you can see I wrote down over here that my common denominator is 10. So step 2 said multiply everything by that common denominator. In this case, it's 10, so you'll notice I multiplied everything by 10. Now, I didn't write that out, so you might need to go back and work your way through this, but basically I took every one of these and multiplied by 10. Okay, so 5 and 10 reduce, leaving a 2, so I get 2x. 2 and 10 reduce, leaving a 5. 3 times 5 is 15. And again, 2 and 10 reduce, leaving a 5. 1 times 5 is 5. So I get this much nicer looking equation. 2x plus 15 is equal to 5. I subtract my 15, divide by 2, and I get an answer of negative 5. Now, it is important to go back and check your solutions. It's not going to be nearly as important here because we didn't have any x's in the denominator, but it's something to watch out for. You should really go back and check. In this case, if you plug it in, you get negative 1. Negative 5 over 5 is negative 1. And negative 1 plus 3 halves is a half because 3 halves is 1 1/2. All right, so that one works. Now let's move into some that are going to have some variables in the denominator. All right, so here's my next example. 1 minus 5 over x is equal to negative 6 over x squared. So the first thing I did was find a common denominator, and you can see I did that. I found it right here. It is x squared. So again, x and x squared are really made out of the same kind of things. They're both made out of x's, right? There are no numbers here with the x. There are no numbers here with the x squared. It's just x's. The thing to remember is that x squared is just two of them, right? X times x. So hopefully we remember from the last video that when we build a common denominator, we just want the most of everything. We don't need x and x squared. That would be x cubed, and it would really lead us into some problems here. We really want that x squared. X squared is going to be plenty. Basically, we need enough x's to get rid of the denominator. That's really what we're looking for here. So we don't need any extras. All right, so I took each piece and I multiplied them all by x squared, and you can see that work right here. So 1 times x squared is x squared. 5 over x times x squared gets rid of an x, so you just get 5x. And for the last one, the x squareds cancel out, leaving the negative 6. So when I bring it back, I have x squared minus 5x minus 6. Now I have to solve this. It's a quadratic. We haven't looked at things like the quadratic formula yet, so probably you shouldn't be trying to use that. But anyway. We can add the 6 to both sides. This does factor. It's x minus 3 times x minus 2. Now, hopefully you remember that when we have things that are in a factored form and it's equal to 0, we can split it up and solve each part separately. So I can set x minus 3 equal to 0 and x minus 2 equal to 0, and we end up with 3 and 2. Now, at the beginning of the section when I gave the steps, I said that you are going to need to check your solutions. So you can see I did that over there on the right. And I'll let you run through that work because there's nothing terribly exciting that happens. It turns out these both actually work. But it is going to be really important, as we'll see on the next example where our solution isn't even going to work. So There you go. There's that one. We got 3 and 2. Let's do another one. All right, so I have one more example, and I appear to have written it right through the middle of the glare on my board. So just pay attention. I'll tell you what's written up there. We have x over x minus 3 plus 3 halves. That's probably the part you can't see, the 3 halves, is equal to 3 over x minus 3. So again, I'm going to start by finding a common denominator. And the important thing here is I only have 2 different denominators. I have the x minus 3's already matched. They are a common denominator with each other, but I also have this 2. So my common denominator is 2 times x minus 3. And remember, what we're really looking for here is that when we get to multiplying by that common denominator, we want all the denominators to go away. So I take the first fraction, x over x minus 3, and multiply by the common denominator. And you'll see then that the x minus 3 cancels with the one that from the common denominator. And so we just get x times 2 is 2x. And I brought that back. Then we did the same thing with 3 halves. 3 halves times 2 times x minus 3. Notice that the 2's go away. 3 times x minus 3. I went ahead and expanded the parentheses. So we get 3x minus 9. Although I didn't write that 9 very well. There we go. And I brought that back. It was plus, so plus 3x minus 9 equals. Did the same thing with the last fraction. 3 over x minus 3. Again, it's going to cancel that x minus 3, and 3 times 2 gives me 6. All right, so here's where we're at. We have 2x plus 3x minus 9 is equal to 6. So I combined my like terms to get 5x. I didn't show it, but I should have. I added 9 to both sides to get 15, and then I divided by 5 to get 3, which looks like a great answer, except that you can see that I already wrote this very funny sounding word down there that says extraneous. So what is extraneous, and why is it there? Well, here's what happens. Remember how I said in the directions, you need to check all of your answers. So even though 3 looks like a perfectly good answer, there's a really big reason why this one isn't going to work. So let's check it. If I plug in that 3, I get 3 over 3 minus 3 plus 3 halves is equal to 3 over 3 minus 3, which leads us over to that corner of the board where we have 3 over 0. Stop. We don't even need to go any further. That's all we need. Okay, it doesn't matter that there's one here and one that we just need a 0 in the denominator. You can't divide by 0. That doesn't work, right? Division by 0 is what we call undefined. Again, to try and wrap your head around that, here is a piece of paper. Very fun, very exciting. Cut it into 0 pieces. You can't do it. So, we cannot divide by 0. That blows up. The 3 doesn't work. So because the 3 doesn't work, you're going to need to get rid of it. And, ideally you'll tell me it's extraneous, but at least cross it out and tell me you don't have a solution. But that's why these will blow up sometimes. When we multiply by things with variables, sometimes we introduce the possibility of a solution where there really wasn't one to begin with. And so it's something we're going to have to watch out for, and we're going to have to be careful with. So always, always, always check your solutions to these. Make sure that they work. Because, yeah, I'm tricky enough that I would put an extraneous solution on the test. So if you've got me, better be careful. All right, thanks, and have a wonderful day.